First of all, I asked you to try this problem on your own, get as far as you can. I said I was going to start today by putting the answer up and then seeing if we have any questions. So there's the answer. Here's how you had it factored: x plus 15 times x minus 11. So set each piece equal to 0 and solve, and you get negative 15, which gives you negative measurements, so it doesn't work. And you have positive 11, which gives you positive measurements, and it does work. Remember that we don't care about the answer for x being negative, we care about the measurements being negative. If the measurements are negative, then it doesn't work. Because we've had problems where, our last example yesterday, we had a negative answer for x, but when I plugged it in, all the measurements were positive, and so that answer ended up working. We took that answer. So make sure you plug in and check those as we go through. So any questions on that problem? All right. We're going on. Next problem, we have M being the midpoint of A to B. We have M being the midpoint of A to B, so we're going to draw a diagram there. So we're going to draw A to B first. Here's A, here's B, and then it has M as the midpoint. So we're going to put M at the midpoint. And we have x squared. This is A to M. And then our 2x minus 3, that's M to B. So again, see if you can come up with an equation here. These are equations that you should know. I pulled these from problems that we've been doing since chapter 1. So if you remember what a midpoint is and what it does, that should give you your equation that you're setting up. And hopefully you remember that what a midpoint does is it splits the segment into 2 equal pieces, which gives me, we should set the pieces equal to each other. Set it equal to 0. I had been saying that we're setting it equal to 0 by using the term with the bigger x squared, so that the x squared stays positive. So left side wins because the other side doesn't even have an x squared. So everything move over to the left side. So we get x squared minus 5x minus 6 equaling 0. And then I'm going quick this time. I'm just going to say that factors into x plus 1 times x minus 6. So remember, we're solving this by saying we have a thing times a thing equaling 0, so one of them's got to be 0. So we're going to set each of those equal to 0. Either this guy is 0 or this guy is 0. If the x plus 1 is 0, I'm going to subtract, and I get x equals negative 1. If x minus 6 is 0, I add, and x is 6. So I have those two possible answers for x. So those are my two possible answers. Remember, it doesn't matter whether x is negative, it matters whether the measurements are negative. So if I take this and plug it back into my measurements, there's what I get. If x is -1, then they're both -5. Notice they're both, in both answers, the measurements are equal to each other. That's what should happen. That's the equation that I set up. I said they're supposed to be equal to each other. But one of those answers I don't want. Which one? The -1, because they give me negative measurements. So I'm going to say that I'm going to use x being 6 as my answer. And for A to B, well, I know A to M and I know M to B. They're both 9. And so if this is 9 and this is 9, then the entire segment is going to be 18. So again, we're plugging in and we're looking for our measurements to be positive. We discounted the -1 and said it's not an answer because my measurements ended up being negative.